Hello everyone, my name is Ken and my advisor is Professor Su and I'm from Functional Nanomaterial Labs and today my topic is simulating plasmons and second harmonic generation in gold nanoparticle with COMSOL. Okay, and then first I want to introduce what is my material, gold. From gold, this is a bulk and we need to put the bulk into nano, and for nano we will have a lot of different shape or size we can see here, like nanosphere, nanoshell, nanorod, nanocluster, nano cage, or nanostar. Okay, here's come first. I want to say about nanoparticles. We can see here in different of the sizes of the nanoparticle we will have a different color. And for the surface plasmon, we can see the electric field is going like this way. And when it go like this way, the electric will go down and up and down and up. It will come out like this one, have the electric field map. We can see here is the electric field. We can see here is the strongest electric field in here. And then this one is for the simulation of the software. We can see when the sizes increase, the peak will a little shift bigger. And then is gold nanorod. We have the same thing with the surface plasma, but for the gold nanorod we have two types of the surface plasma. One is the longitudinal side, one is the transverse size. And because of this kind of the surface plasma, we will have two peaks in the absorption. We can see in here. And increasing the aspect ratio, the peak will change it. And we can see in the first one, this is gold nanoparticle. We can see a peak is in here. And the aspect ratio bigger and bigger, we can see is longer and longer. We will have two peak in here. First one and the second one. And here is the simulation in here. This one is for experiment, and this one is for the simulation. We can see here. Here have the strongest electric field in here. Yes. And then this is my work, gold nanoparticles. And this is my gold nanoparticles after experiment. And then I go to UV visible. I need to check out what is the absorption peak, and we can see it's around like 520 or 25, yes, in here. And then this is DOS. What is DOS is we can see the particle size. We can see it's around 420 to 45, and the average is around 32.9. Okay, this is my COMSOL simulation of the absorption and the electric field. We can see here, because of my sizes is around 30, so I make the model around 30, and we just put the electric field like this way. We can see here have a very strong electric field. And then after this we can go into the absorption. We can see the peak is around 525, or it match with the previous sample with my experiment part. And here, this is I'm trying with my model with a reference. We can see here all of them is the same sizes of the gold nanoparticle, and when they go near, the electric field in the middle will be higher and higher, like this one. when the distance in the middle lower and lower, the intensity will be higher and higher. We can see this one is the nearest, is 10 nanometer. We can see the intensity is the highest, like 8 times 1010. Okay, and this one is the electric field scanning for myself in the COMSOL. We can see first in here, this is my model. We can see we put 2 nanoparticles in here, and the distance is 40, the radius is 20, and we can put them together and see this one is the electric field map, and this is the scanning line. And this part I put 2 particles in 5 nanometer. The distance is 5 nanometer, and we can see in the middle the electric field is very strong. And going to the XY axis, we can see here. Yes. Okay, and for my topic, I want to say what is second harmonic generation. The second harmonic generation is when I have a laser with alpha going to the nonlinear optics of a crystal, and like 90 or 95%, it will go out like omega 2, but some of them it will go out in the 2 omega. We can see in the second graph. This one is the laser I put in, and sometimes if my crystal or my material is in nonlinear optics, it will have 2 omega. It will have stronger energy in here. Yes. And can I have a gold nanoparticle showed in SHG? Yes, because I have seen some paper. We can have this one. Gold nanoparticle or silver nanoparticles in second harmonic generation. So I'm trying about this. And then this is my goal. I want to put single nanoparticle on the subject and going to shine the laser and go into SEM to make sure what is this. And then because of my subject, I want to use this one, PVA, to let my goal to be more uniform. Because for the water, my gold nanoparticle will look like this one, will aggregate in the middle. And if I use PVA, the PVA is like a glue, and it will let my gold nanoparticle be more uniform, and I can have more particle like this one, simple, single one. Okay, and this is my COMSOL simulation of the second harmonic generation in gold nanoparticles, and this is my reference. I look this paper to make my model, and now this is a gold nanoparticle in the far field with the second harmonic generation. We can see here in the G. This one is the paper they want to make the gold nanoparticle in the second harmonic far field. So I think in this kind I just a little match with them. So I'm just keep going on this one. And then is my conclusion. Gold nanoparticle synthesized with size around 32.9, and the absorption is at 5 to 3 nanometers. COMSOL modeling done to confirm absorption and surface plasmon in gold nanoparticles. Second harmonic simulation with COMSOL under progress. Internal result in core green. And my future work, simulate the near field and the far field for the second harmonic or in the gold nanoparticles or gold nanorod, study the polarization effect, and change my medium like water, air, glass, and change my material like silver, gold, or silicon. And thanks for